So, hey everyone, let's solve another question from Striver's A to Z sheet. And the question is next permutation. Okay, so in this question, we have given an array and we have to find the next permutation of the given array. For example, the permutations of 1, 2, 3 are 1, 2, 3, 1, 3, 2, 2, 1, 3, and so on. So, the permutation is basically the elements, core elements must be the same, or the arrangement may change. For example, the permutation of 1 to 3 are these, and each of these elements have different arrangement of the core values. Okay. So this is basically the permutation. And what is next permutation or greater permutation? Greater permutation of 123 is basically 132. Why is that so? For example, 1, 2, 3 is the number. So if I want to find the greater permutation of this, 3, 1, 2 can also be a greater permutation because 312 is actually greater than 123. And what's 213 can also be a greater permutation, but I have to find just next greater element. Okay, next permutation. So the next permutation according so for this uh, element there can be multiple greater elements, but I have to find just next. So if I change the suffix, if I change the prefix, there can be different values, but I have to keep it minimal. So let's not change the prefix. Let's keep it same. Let's say I have one and I want to find the greater element. Now, if I interchange the positions of 3 and 2, I will see that I can get a number 132. Okay, 132. This number is actually greater than 123. So, and there is no other number that is smaller than 132 and greater than 123. So, basically, 132 will be our answer here. Now, I want to find the greater element of this array. Okay, the next permutation of this array. How can we find it? uh, Basically, I will try to not change the prefix, but I will try to change the suffix. But I can see that this part of array is already at its maximal. Okay, so I can find. Finally I will have to change the prefix. So it will be like 3, it will be like 2, which is just greater than 1, 2, and now I have to minimize the suffix, which will be like uh, 1 and 3. So the approach was like find the next greater element of the breaking point and then finally sort the remaining suffix. All right. So I can see that first the trend was increasing and then it decreased. So when the trend decreased, that means that is the point where I have to change the prefix. Okay. And in this case also, the trend increased, which is 3, and then it decreased. And at this point, I can see that there is a possibility of generating just greater elements. Okay, so this is what I have to do. First, the trend should increase. Okay, let's take another example. 5, 4, 1, 6, 7, 8, and 2 and 5, 6, 5. I can see that the trend is increasing and then it decreased. So I can see that there is a possibility of interchanging the just greater element of 5. So I will change it. So I can see that it is already here. So it will be like 6 and 5. And now I should sort the remaining part of the array. So this is what I have to do. Okay. First, first find breaking point of trend, then sort the right portion of the array, then swap, then swap the just greater element. That will be our answer. Okay, so let's start coding. Let's start the code. Let's create a pointer int p is equals to nums dot size minus 2. Okay, while p is greater than equals to 0 and nums p is greater than or equals to nums p plus 1, then what should I do? I'll decrease p by 1, p minus minus. Okay, this is done. Now I have to sort the elements beyond the breaking point. Sort nums dot begin plus p plus 1. That will ensure only the numbers beyond the p are sorted and no else the number before p or including p are not sorted. Okay, and now start and okay, this is done. I can ensure that if p is, let's say if p is zero, okay, the condition will break, and if p is minus one, the condition will break, and p will be like it will the this value will be like zero, and the array will be sorted from beginning, and that case will be of 4, 3, 2, 1. In this case, I can see that there is no breaking point. All the elements were just increasing. So the next permutation for this array will be like 1, 2, 3, and 4. This is the next permutation. So this part is also ensured. Let's say if p is smaller than, let's say p is smaller than 0, then return. Okay, this is the if p is not 0, if p is not negative, then what should we do? We will have to swap the element. Okay, so int j equals to p plus 1 for j. J should be smaller than nums dot size and j plus plus. Okay, if nums j is greater than nums p, then break and then swap nums p comma nums j, okay, and finally submit the return. Okay. So this is the code. First of all, we checked for the breaking point, and this part is for sorting the elements beyond the breaking point, after the breaking point, and this part ensures that if p is actually 0, actually minus 1, so we don't have to look for these values, this thing. So we will simply return the code. Else, we will start looking for the number which is just bigger than the current element. This code has done that thing, and finally we have swapped the just bigger element and the current breaking element, and finally we have returned the code. So this was the summary. Let's submit. Let's run the code if it is working fine. Yes, that's working fine. And let's submit the code. It is taking time. Yep, our code beats 100% of the people. The code was the approach took of n log n time complexity.